All right, next up, I'm going to explain the reasoning for a half angle identity. So we're going to take a look specifically at this one, the sine of alpha over 2, or sine of half an angle. Now the reason why is using one of those cosine or double angle identities for cosine. So if I've got the cosine of 2 theta, according to the stuff that we are doing in the previous video, that would be equal to 1 minus 2 times the sine squared of theta. So choose that one specifically because I'm going to try and now get sine all by itself. Okay, I'm going to have the sine of theta. If I were to do that, I would add 2 sine squared theta to this side, and I would subtract cosine 2 theta from that side. So in that regard, I'd have something like this. 2 times the sine squared theta is equal to 1 minus the cosine of 2 times theta, or twice an angle. Then, as I'm continuing to work to solve for sine, I'd probably divide both sides by 2, and I'd have sine squared theta is equal to that thing over 2. So 1 minus cosine of twice theta all over 2. And then, if I were to take the square root of both sides, the square root of sine squared will be just sine. So I'd have the sine of theta is equal to the square root of all this. And it would be both positive and the negative. So both plus or minus the square root of 1 minus the cosine of 2 times theta all over 2. Now this almost matches what you see here. Okay. The difference is now in the cutting an angle in half part of this. So here I have theta, here I have alpha over 2. Okay. Here I've got 2 times theta, here I have just alpha. So what I'm going to do is I'm going to just write that over here, and you can do the same. What we're going to do is we are going to replace, okay, or substitute. We're going to replace 2 theta, 2 times an angle, with alpha. Okay, some other angle, just using a different variable. So if 2 theta, 2 times an angle is equal to alpha, well then alpha would be equal to, or excuse me, theta would be equal to alpha, that angle, cut in half. Okay, so then if I replace the expressions within this thing with those two things, so I'm going to replace, there'll be the center of the sine of theta, it's going to be the sine of an equivalent expression, which happens to be alpha over 2. So the sine of half of some angle is equal to the square root of, and I should put plus or minus there, I suppose, 1 minus the cosine of that angle, okay, alpha, which is double some other angle, okay, all divided by 2. So there we would have our half angle identity for sine. And to find the other ones for cosine and for tangent, it'd be kind of a similar process, but I'm not going to go through that now. So we'll just be good with that. And if you want to take the time to find the other ones, you certainly are welcome to, but I'm going to quit with that one. Okay.